Hey everyone, just thought I'd make another quick video. So today I wanted to be a little educational on what the difference is between firecrackers and dynamite or TNT. And to put it simply, both of them explode. Obviously, because dynamite and firecrackers are two very different things, it shouldn't be very hard for me to explain the difference between the two, and maybe it would clear up some confusion for many of you guys telling me that firecrackers are like bombs and look like sticks of dynamite. There's no doubt about it that firecrackers and other fireworks may have the title such as dynamite on them, but this is highly inspired as there are no firework chemicals out there legally which contain nitroglycerin or trinitrotoluene in them. This is in fact the big primary difference between firecrackers and dynamite, where dynamite is made to detonate and firecrackers deflagrate. Deflagration and detonations are two very different things. For starters, a detonation is simply when the pressure waves travel faster than the speed of sound, and this is due to an insane amount of force in the shock waves produced by nitroglycerin, TNT, trinitrotoluene, and so on. Firecrackers, on the other hand, are made with a very different composition. If any of you guys have ever taken a firecracker apart, you will notice that there is a white, kind of silvery, almost dark kind of powder. This is known as flash powder and has nowhere near the amount of force of trinitrotoluene or nitroglycerin in dynamite. It seems that right off the bat there is a big misconception with lighting off these firecrackers, and they make a huge plume of smoke. There's no doubt about them being incredibly loud, but due to the smoke at hand with them, this does indicate incomplete combustion. Therefore, without a sufficient supply of oxygen, there is tons of smoke. Dynamite chemically decomposes faster than the speed of sound, and rather than burning, it can only be detonated with an initiated powerful enough shockwave. If you simply took a lighter onto a stick of dynamite, it would not explode. Obviously, this isn't something you should ever try or test. Henceforth, sticking a fuse into dynamite will not cause it to explode either. It simply requires a shockwave in order to go boom. This is why blasting caps were invented, but we're gonna save that topic for another day. I have done a video before on M80 firecrackers and where they come from, and this indeed, I believe, brings up the topic of dynamite and quarter sticks and M80s. This indeed is another high area of confusion that I would love to clear up, and I can't be perfect about it, but many people out there love to categorize M80s as quarter sticks, half sticks, or full sticks, which in turn brings up the confusion about dynamite or TNT. Since I've already explained that they are two very different things, perhaps what makes a firecracker loud? For firecrackers, most of them are in shapes of cylinders. Some of them may have spherical shapes, such as on top of salute rocket headings, or in the shape of a canister, such as a canister salute firework. Each and every one of these confinements for flash powder works perfectly great, and of course, it will go boom. But to make this more interesting, I thought it would be cool to explain what makes a firework loud, which confinements are the best, and how do the mathematics play out. I have not shown this formula to very many people, obviously because firecrackers are loud enough, the math really doesn't even matter at this point. However, assuming that there is a great amount of force with flash powder in the firecracker, the only thing left that you have to worry about is the surface area in the confinement, which I will start off by saying wider opening tubes for M80s such as 1 inch and above ID will not, and I repeat, will not be as loud as a much thinner tube such as 3/4 ID. There are obviously differences in pitch when you go to light off these firecrackers, because larger confinements will have a lower frequency, whereas very small amounts of surface area have a nice sharp crack, an example a higher frequency, to their explosions, which in turn the pressure wave is directly proportional to the loudness or volume of these firecrackers. As for a spherical firework break goes, depending on the confinement, it has to be a near perfect sphere. Because the force distribution is near equal in each direction, the loudness is just about maximum. As for dynamite, a mixture of sawdust and nitroglycerin is packed into tubes and placed in designated locations for detonation. If you wanted a firecracker to be louder, do not pick out a confinement that has a ton of surface area. area. I would suggest using longer tubes that are in the shape of dynamite, and perhaps if you can find it, a one-piece fiberglass or cardboard sphere. But if you enjoy lower frequency firecrackers, higher amounts of surface area may be your best choice. Most consumer fireworks salutes do not have to worry about this formula because they do not want their fireworks obnoxiously loud. From personal experience, using smaller amounts of surface area in your confinement space for firecrackers will indeed make them ungodly loud. I hope this video cleared up just a little bit of confusion for you, and remember that the next time you hear a half stick, quarter stick, or full stick firecracker, it probably does not refer to dynamite or TNT in any way. Well, that wraps up this quick explanation. Remember to always be safe with fireworks, and hey, if you'd like to check out my 4th of July video where I actually lit off very loud firecrackers, go ahead and do that. Otherwise, you guys are awesome. Check out some of my other content, and I'll see you next time.